Yes. Hello students, how are you? I hope you all are doing good. Is everything is fine? Hello. Hello all. I hope you all are doing good. Yes. So we don't have any issues here. So we can start discussion as far as my knowledge is concerned. Okay. So shall I start our discussion, guys? Please let me know through the chat box. Can you hear me? I don't know why, like there are some students who are yet to join. Guys, can you hear me? If you am I audible to you, please let me know through the chat box. If I am audible, please let me know through the chat box. Yeah. So now I think there is no issues till now, right? So there are some schools who have joined through YouTube and all. And so let me tell you, yeah, good afternoon, guys. Thank you so much for your response. And let me keep the things very clear first. Okay, so everyone, please open your pen, open your books, and take your pen. Okay, so this is class is going to be very, very most important, guys. I know very, very most important thing is like you might have got your pre-board results now, and many of the pre-board results are not up to the mark. And some of you might have fear that how I can get good marks in chemistry. I don't have, proper knowledge in this, what we are going to call organic chemistry, how to do organic chemistry. This is the biggest problem, right? So these people are telling to attend enable classes, how to focus all these things. And JEE mains is there from 24th onwards, pre-board is there, and another practical exam is there. So now there the 12th people might have feeling a lot of headache is going to take place. But honestly, I'm telling you guys, no need to worry about anything. Just focus on the present class now. Just close your eyes once. Just feel key. You don't have any stress in your mind. Just take a long breath and just, okay, just release it out. So now close your eyes, take a long breath and just release the pressure there. Just feel you are relaxed. Take out the pen and paper, take out the pen and book and start working on it. Okay. So today I am going to teach you about alcohol phenol ethers. Okay, before that, I will ask you some of the recall questions. So let's recall some of the IUPSC questions. This is a kind of, orientation question. And I'm believing you that you people will follow me. Take pen and book and start working on it. So I would like to ask you some of the IUPSC names, okay, which are coming in the CBSE examination. And I'm going to cover CBSE simultaneously, some JEE and NEET questions. So try to find out the IUPSC names of these compounds. Okay, guys, chalo. Okay, are you guys ready? Just answer this IUPSC name. Okay, what is the IUPSC name of the compound? Come on, people, you have to tell me what is the IUPSC name of the compound? This is asked in CBSE 2017, and this question is asked in NEET also. Come on, what is the answer for this one? Please do tell me in the chat box. My dear YouTube friends, please do reply in the chat box. What is the IUPAC name of the compound? Come on, people. Right? What is the IUPAC name, guys? Please mention in the chat box. Yes. So now whenever there is any functional group is there, alcohol is a functional group. So it will get number 1 and it will get number 2. Now this particular group is simply benzene attached to the main functional group. Here parent chain. What is parent chain here? Here parent chain consists of 2 carbons. Okay. So then that is ethane, where there is a single bond is there, ethane. And here functional group is alcohol. Functional group is alcohol is there. And here what is the substituent? Substituent is what? What is the substituent here? Benzene. We don't call it as benzene. Whenever the benzene is acting as a substituent, we call it as a phenyl group. Which group? Phenyl group. So now remember how to know whether that particular group is substituent or not. You have to first see where the OH is attached. If any functional group is attached to the carbon, if any particular functional group is attached to the particular carbon, and these particular carbon will give the number 1 priority, the number 1 and number 2. And here again there is a termination is taking place where the benzene has been attached to this CH2. Now we don't call it as benzene because we call it as a substituent. So substituent will always called as phenyl. Now try to name this one. How do you name this one? At second position you are having phenyl, and at first position you are having alcohol. So now we can simply write it as 2-phenyl ethanol. You can simply write 2-phenyl ethanol, or you can also write 2-phenyl ethane 1-ol. You can also write 2-phenyl ethane 1-ol. I don't want to waste much time. This is what you can easily answer, right? So next one is try to answer this one. CH2OH, CH2OH, and CH2OH. So try to name this one, guys. Come on, everybody. You can easily name this one. We have already seen this. Again, this question, this is commonly called as glycerol. What we are going to call it as glycerol. Where we use glycerol? In soap. Here soap. Generally, where you need more foam and clear, skin, which we use in cosmetics. There we will use glycerol, and glycerol is this one is glycerol. So I am going to give you some homework. So you need to find what is glyceraldehyde. What is glyceraldehyde? So what is glyceraldehyde? This is your homework, but this is called glycerol. So just think about glyceraldehyde. Yes, definitely there is aldehyde group is present, but I want you to find what is glyceraldehyde. Okay. So now how do you name this one? So just assign number 1, 2, 3. So these are the main chain where you will have 3 carbons. So then we are going to call it as propane 1, 2, 3 triol. 1, 3, 1, 2, 3 triol. Why? You are having 3 alcohol groups. We are having what? 3 alcohol groups. So that is why we can also call it as 1, 2, 3 triol. I hope everyone is clear with this, right? Is it clear to you all? Please let me know through the chat box, guys. Please let me know through the chat box. Okay. Yes. Now, next one. Very, very most important. Next one. Now, I don't want to waste much time. I'm going to give you one homework question and try to answer this one. So try to write down X in, okay, 3-ol, or you can also say that X1 in 3-ol. So this is your homework question. So try to find the structure. I have given you the compound name. You have to find out the structure. Whenever these kind of questions are coming, you have to first see the root word. What is root word here? hex. And what is the secondary suffix, primary suffix you have to see. So functional groups are already secondary suffix, and in, ein, wine are the primary suffixes. So now here in is the suffix and along with all is the suffix. So just hex means 1, 2, 3, 4, 5, 6. 1 in means 1 and 3 all 1, 2, 3. So here alcohol will be present. So this is the structure. Just from the basics, guys. Okay. Don't stress too much. Right. Next one. Very, very most important thing. And another very most important example. So try to see this example, guys. Okay. See this example. CH2, CH, bond OH, and CH3. Just now I have given homework. So this is the homework for you. So try to solve this question. Okay. So find out the IUPAC name for this compound. Just take out your notes. Don't sit, don't write practical records. Don't write, any other subjects. Just focus on chemistry. Today we are going to do alcohol phenol ethers a bit. Okay. I don't want to waste much time of yours. Chalo, come on, guys. Next one. What about phenols? What about phenols, guys? Phenols, we need to know some of the important names. Cresols. What is cresol? In your NCERT, it was clearly there. Orthocresol, metacresol, and paracresol. Simple, we are having a phenol group. So this is phenol group. And if CH3 is attached at the ortho position, we call it as orthocresol. If it is attached at the para position, if it is attached at the meta position, then you are going to call it as M-cresol. Okay, cresol is simply nothing but substituted with methyl group. Next one is catcall. Catcall is simply nothing but where phenol is attached with another hydroxy group at ortho position. Catcall is at ortho position. Next one is resorcinol. Resorcinol. Resorcinol is simply nothing but where the OH is attached at meta position. Next one is phenol, or we can also say that hydroquinone. Hydroquinone. Okay. So hydroquinone. So where the OH group is attached at the para position. So everyone need to know if there any particular group, if any functional group is present here, and these positions are called as ortho position, and these positions is called as meta position, and this particular position is called para position. Okay. So what will going to happen for this position? This position is also meta position. This position is also ortho position. Don't get confused. Whenever you are having a functional group, any particular functional group is there. So these position is called as ortho group, meta group, para group. And you might have two ortho groups and two meta groups, but you will have only one para position. Okay. So now this is catcall, resorcinol, and phenolene. And these are the common names we are going to call them as. But how do you call them when for the IUPAC? So how do you call the IUPAC name here? And here, let's suppose benzene is there. Benzene is there, and you can clearly say that 1,2 diol. Okay, so you can see number 1 and number 2. Okay, so we are going to give number 1 for this OH and number 2 for this OH. So then we can call them as benzene 1,2 diol, and then we can call them as 1,3 diol. We can call them as 1,4 diol. I hope everyone understand this one. Right. Next one, very, very most important, picric acid. In your CBSE exam, also, there is a question called, what is the IUPAC name of the picric acid? Picric acid is a common name. What is the IUPAC name of the picric acid? Just as simple as that. Okay, so this is the picric acid. So picric acid, many people will feel that acid means OH will group, COOH will be present. No. Acid means OH group will be present. Oh, acid means we can call phenol is also called as carbolic acid. Yaad rakhna, we can call it as a carbolic acid. We can call it as a carbolic acid. Commonly, phenol groups will also possess acidic character. Okay, why? Because this H plus can easily remove and forming a phenoxide ion. So that is why phenols are also called as acids, not general alkyl alcohols. Yes, in alkyl alcohols also some acidic strength will be developed, but whereas phenols are more acidic than alcohols. The reason, because of more polarity, that is minus I effect of the this particular ring, or we can also say ionization. After ionization is taking place, this will undergo resonance. We will discuss that one later. Forget about this. But picric acid is this one. So how do you name this one? How do you name? Again, 1, 2, 3, 4, 5, 6. So then we can call it as 2, 4, 6 trinitrophenol. Okay, 2, 4, 6 trinitrophenol. This is what you people need to remember. Just I am giving you the homework, and which is very, very most important. And 2015, this question came in your CBSE. Try to answer this one, guys. Try to answer this one. Yes. Okay. So try to answer this one, guys. Very, very most important for your examination. What is the answer for this one? This is a homework for you. I'll just give you the hint. 1, 2, 3, 4, 5. This is one kind of naming. Okay. So you can also give the other naming too. So, but you have to check the lowest sum rule. You have to check the lowest sum rule. Many people will also get confused. Sir, why don't I go like this? Why don't I go like this? Like 1, 2, 3, 4, 5, 6. If you see the position of the substituents, 3, 6. If you see the position of the substituents, 2, 5. So 2 plus 5 is how much? 7. This is at the second position and this is at the fifth position. Okay. So this is at the second position and this is at the fifth position. So that is why 2 plus 5 is 7. But here 6 plus 3 is 9. So this is the lowest, this is highest number and this is lowest number. So this is how you will proceed. Okay, guys. Yes. So next one is ethers. Just make sure that we are doing everything fastly and we are learning. It's not simply ki I'm just telling and everything and all. Very, very most important rule whenever you are naming the ethers. Okay. Naming the ethers, you all should know some rules. Okay, so let's suppose if you are having ROR, so this is ether, right? So whenever if R is less number of carbon than this particular group, then this is called as alkoxy group. What you are going to call it as? Alkoxy group. Okay, so then you are going to call it as alkoxy group, and simply you can call it as alkane. Then simply you can call it as alkane. Generally, if you are having CH3O CH3, common name, what is common name for this one? Common name what? 2 methyls are there. 2 methyls are there. So that's why dimethyl. This is ether group. So the ether you simply call it as. But what is the IUPAC name now? What is the IUPAC name? What is the IUPAC name, guys? Very simple. We call it as alkoxy group. So that's why alkoxy, but here methyl is there, so that's why methoxy, and here methane is there, methoxy methane. What you are going to call it as? Methoxy methane. So very, very most important. So how to pick? Many students will have a doubt, sir, how to pronounce whether I need to take this or I need to take this. Simple. Where there is a less number of carbons, you call that particular group as alkoxy group. No clear? Just I will give you a clarity. Nothing to worry much about. Let's suppose CH3, O, CH, CH2, CH2 and CH3. I hope you guys understand. Okay. So now see here, this particular is a lowest group. Oxygen ke side. Here how many carbons are there? 3 carbons. Here how many carbons? 1 carbon. So these particular group will become alkoxy group. So then we can call it as methoxy. How many carbons? 3. So then you can call it as propane. What you are going to call it as? Methoxy propane. This will be the IUPAC name. This will be the IUPAC name. Then what about the common name for this one, guys? What is the common name here? Common name is very simple. Common name is methyl. Okay, N-propyl ether. Methyl is there and propyl group is there, N-propyl ether. So this is what we are going to call it as. Now, shall I give you the homework, guys? Shall I give you the homework? Okay. Shall I give you the homework? Yes. So try. What is the name of this one? Tell me. What is the name of this one? Yes, sir. We know this. This is simply called as enizole commonly. But what is the IUPAC name? Yes. So here only one carbon is there. So that is why methoxy. And here this is benzene. So that's why we call it as methoxy benzene. Okay. So now I'm going to give you another homework. CH3O, C, CH3, CH3, and CH3. I want you to answer this one. How do you answer this one? Come on, guys. Tell me in the chat box. How do you answer this one? Right. So whenever you are answering this one, just assign the numbering 1, 2, 3, because this will be the main chain. Always remember, OR group is always take as substituent. OR group is always take as substituent. OR, NO2, okay. See that all the halogens are sulfide ions and imide ions. All these all are acting as substituents. Okay, just remember this one. So now this will become substituent. This will become substituent, and now these all are the this is the main chain. Now you can say that 2-methoxy, 2-methyl, 2-methoxy, 2-methyl. Okay, propane, 2-methoxy, 2-methyl propane. While at the second position you are having methyl group and simultaneously methoxy group. I hope you all guys understand. OR is always taken as what? Substituent. I hope everyone is clear with this. Okay. So next, moving forward, I don't want to waste much time here. Just directly, I'm giving you one example. Then try to answer this one. Okay. So answer this question and then I will move on. Try to answer this one. Yes, I want you to answer this one. This question came in CBSE 2012. This question came in CBSE 2012, guys. And this kind of questions will also observe in NEET exam too. Okay, come on, people. Please do answer this one. Yes. How do you answer this question, guys? Come on, tell me. Yes, same scene here. We have to see with respect to this side more 1, 2, 3, 4, 5, 6. 6 carbons are there, but here how many carbons? 2 carbons. So this particular group will become what? Alkoxy. Alkoxy group it will become. That means ethoxy, because 2 carbons are there. So that's why we call it as ethoxy group. Why? Less number of carbons is always considered as alkoxy group. Less number of carbons beside the oxygen is always considered as alkoxy group. Now this will become ethoxy group. Very clear. This will become ethoxy group. Now, sir, between OR is there and NO2 is there, where we'll give the preferential first? Where we'll give the preference first when we are giving the numbering? Here you can see, depending upon R, you have to give the numbering because both are substituents. Both are substituents. This is substituent, this is substituent. Now, if O is attached with CH3, we call it as methoxy group. And this is nitro group. So preference will be go this side. And if O is attached with CH2, CH2, CH3, then we are calling it as propoxy group. And here NO2 is nitro group. So now preference will go to this side. But here, R place mein kya tha? Ethyl group. So then we can clearly say that OC2H5 will have more priority than NO2. So the numbering will start from here. 1, 2, 3, 4, 5, and 6. So at first position, you are having what? Ethoxy group. Ethoxy. And at the second position, you are having nitro group. 2 nitro, And overall, what we are going to call it as cyclohexane. I hope everyone is clear with this. I hope everyone is clear with this. Please let me know through the chat box. Please let me know through the chat box. 1-ethoxy, 2-nitrocyclohexane. Is it clear, guys? Come on, people. Please do respond in the chat box. Yeah. Is it clear? Buldana school, anyone school, you people have an access, right? See, I don't want any appreciation or I don't want anything, okay? So I just want some encouragement so that I feel you are listening to my class. Or else I feel like it's something I was doing and you people are telling something. I'm requesting you guys to please respond in the chat box whether you have understand this IUPAC naming or not. Come on, people, please let me know through the chat box. Guys, please let me know. Very good. Rajkot team is always supportive. Thank you, Rajkot team. I'll definitely inform to our DC sir that our Rajkot team is very supportive, right? Whenever we are having a meeting with our DC sir, I'll inform which school is very interactive and all. We'll try to have a awards to the schools who are having more interaction. Okay. Yeah. Thank you, Buldana, my old school. Yes. Yeah. So now, very most important, preparation of alcohols. Next one is what? Preparation of alcohols. Preparation of alcohols. So how do you prepare the alcohols? So alcohols are basically prepared by so many methods. First one is acid catalyzed reactions. Acid catalyzed hydration, not reaction. Acid catalyzed hydration. Acid catalyzed hydration. Okay. So how do you do this acid catalyzed hydration? What the first thing you need to remember? What is the reagent for this one? Reagent is pretty simple. You all know H plus in the presence of H2O. So acidic hydrolysis in the presence of H2O. Or they may also give like this HCl in the presence of H2O. Or they may simply give like this H3O plus. So if you see these three reagents, then you can easily feel that you are going to do acidic hydrolysis, or we can say acid catalyzed hydration, or we can also say that acidic hydrolysis. Okay, so let's see what is going to happen with this particular reaction. Let's suppose if I am having CH3, CH, double bond, CH2. This is an alkene group, and I have doing H plus in the presence of H2O. What will be the product? Always remember, acid catalyzed reaction will undergo Markovnikov rule. Acid catalyzed reaction will undergo Markovnikov rule. So now tell me what this Markovnikov rule tells. Markovnikov rule will always tell that electrophile will, especially H plus, that is proton, will attack on the carbon where number of hydrogens are more. Okay, so electrophiles usually attack the carbon where the number of hydrogens are more. And what about nucleophile? Nucleophile will attack on the less number of hydrogen contained carbon. Less number of hydrogen contained carbon. Very most important. Okay, Markovnikov rule suggests that H plus will attack the carbon where you are having more number of hydrogens. Now this H plus will have a chance to attack here. Let's suppose this is A carbon and this is B carbon. Now, as per the Markovnikov rule, where H plus need to attack, it will attack on the hydrogens. It will attack on the carbon where the number of hydrogens are more. So here number of hydrogens are 2 here. So the H plus will attack here. So now you can clearly say from here, that is CH3, CH, double bond, CH2. Now my H plus will first attack on this. Now it is going to form a carbocation. Here you are going to get positive charge and here you are going to get CH3. Okay, so it will break and here you are getting partial positive and here you are getting partial negative. So that's why This H plus will attack here. Now you got a secondary carbocation because what? Two carbons are attached, so then you can call it as secondary carbocation. Okay, so now whenever secondary carbocation is formed, you have to see is there a chance of formation of tertiary carbocation or not. Okay, whenever secondary carbocation is formed, you have to see there is a chance of forming a tertiary carbocation or not, you have to see. Okay, so now next, what is the second step here? This still here we have got, and next you are having H2O. And we know for H2O, we are having electrons on here. So now H2O is acting as what? Nucleophile. H2O is acting as what? Nucleophile, which is a neutral nucleophile, carries the electron here. Now this H2O, which is having electrons here, and it will attack the carbon, Now what will going to happen? CH3, CH, here oxygen is attached. When the oxygen is given its lone pair, it will get what charge? Positive charge on oxygen, and simultaneously that CH3 will be present as it is. Now, whenever any electronegative element like oxygen or nitrogen giving their lone pairs, then what is going to happen? They are going to have a positive charge over them. Why? Even if you check the formal charge also, 1, 2, 3, 4, 5. So one electron is less, so that's why you are getting positive charge here. Now positive charge on more electronegative elements like fluorine, nitrogen, oxygen. Positive charge on the electronegative elements, it will become unstable. So to become stable, what will going to happen? They will take the shared pair of electrons. From this hydrogen and making this hydrogen as free from H plus. So now the new answer will become CH3, CH, bond OH and CH3, and this H will go as H plus. So here you can clearly say from this is secondary alcohol. This is what? Secondary alcohol. I hope everyone is clear with this, right? Okay, I hope everyone is clear with this. Okay, so this is what, let me show you some of the questions so that you will feel confident. CH double bond, CH double bond, CH3. Now if I am doing acidic hydrolysis, or else H in place of H plus, let's suppose H2SO4 is there or HCl is there. Also, you can, these kind of reactions are possible. Okay, but generally H2SO4 will not be given, but in your examination they simply say acidic hydrolysis, or they will simply mention as H3O plus, which is also called as hydronium ion. What you are going to call it as? Hydronium ion. Okay, which is also called it as hydronium ion. Now pretty clear that, forget about this one because these all are will give H plus ions. This will also will give H plus ion, but depending upon the temperature. So if there is H plus, the interesting fact here is one hydrogen and here also one hydrogen. So irrespective of the position, it can attack wherever it want, right? Irrespective of the position, right? Now I am going to tell you. So now what will be the final product here? CH3, CH, and this hydrogen will attack here, and we can clearly say that CH, CH3, and here OH will attack. Just remember. Okay, so next one, another example, if I can give you, CH3, CH double bond, CH, let's suppose CH2, CH3 is there, and this is CH2. Now if you are having H plus and H2O, then what is the answer, guys? CH3, CH2, CH bond CH2. Here Here OH will attack and here H will attack. Okay, the simple C point hai, where here one hydrogen is there and here two hydrogen is there. So hydrogen will attack this particular carbon, and from H2O you will get what? OH minus. Just simply remember this one. This will go on the less number carbon. This will go less number carbon. This is what you people need to remember. And another one is rearrangement is also possible. Another one is rearrangement is also possible. It's also possible. Just remember, I will give you some examples here. Then you can easily calculate. Okay. So now let's suppose see this one. CH3, CH, bond, CH3, CH, double bond, CH2. And if I'm giving you H plus and H2O, obviously here one carbon, one hydrogen is there, here two hydrogens are there. So H plus will attack at the two hydrogen contained carbon. And now what will be the answer? CH3, CH, bond CH3, CH positive charge, and here CH2, H will be there. Now, what is the carbocation formed here? What is the carbocation formed here? Here, this is two carbons are attached. So this is secondary carbocation. What is this? This is secondary carbocation. Now you have to see, can I make it as a tertiary carbocation or not? You need to see, shall I make it as a tertiary carbocation or not? Okay. So how you can make it as a tertiary carbocation? Yes, very good. Many people might have thinking about rearrangement. What is that? Rearrangement. Sir, how do you rearrange? See whether this hydrogen, okay, rearrangement can be done by hydride shift. Which shift? Hydride shift. We can also call it as 1,3 hydride shift. 1,3 hydride shift. 1, 2, 3. So here, this hydride will be shift here. So now, let's suppose if I'm shifting the carbocation here, if I'm shifting the hydrogen here, what will going to happen here? Just see this one, CH3, C, you'll get a positive charge here, and CH3 here, CH2 and CH3. So you got positive charge here. Now how many carbons are attached? 1, 2, 3. 3 carbons are attached with positive charge. So that is why this is tertiary carbocation. So tertiary carbocation is more stable than secondary carbocation. So then definitely this is a carbocation formation is there. Then now your H2O will attack here. Now at the end product will be CH3, C bond OH, CH3, CH2, CH3. I hope you all guys understand this one. You all guys understand this one. Very, very most important. Is it clear to you all guys? Please let me know through the chat box. Is it clear to you all? Is it clear to you all? Tell me in the chat box. Is it clear to you all? Why rearrangement we have done? We have to see whether there is a expansion is takes place or not. Is it clear? Right? Very good. Yes. Okay. So we are having another 3 minutes of time. Next we will go to hydroboration oxidation. Okay. So next one is second one. Second one is very, very most important, HBO. It's not HBO channel. This is hydroboration oxidation. What is that? Hydroboration oxidation. Hydroboration oxidation. How do you do this one, hydroboration and oxidation, guys? Tell me. Hydroboration oxidation, can you tell me? So first of all, you have to know what is the reagent here. What is the reagent here? So how do you know the reagent here? The reagent is B2H6, okay, in the presence of H2O2 and tetrahydrofuran. Okay, so if you see these kind of reagent, these will undergo anti-Markovnikov rule. कौन सा rule है? Anti-Markovnikov's rule. So what is anti-Markovnikov's rule? Markovnikov's rule will say that H plus will attack on the less number of hydrogen contained carbon. H plus will attack on the less number of hydrogen contained carbon. And whatever the nucleophile is there, that will attack on the more number of hydrogen contained carbon. More number of hydrogen contained carbon. नहीं सर मुझे समझ में नहीं आया, कुछ एग्जाम्पल बता सकते हो? वेरी गुड, जस्ट सी दिस वन, CH3 CH double bond CH2, and here you are having B2H6 and in the presence of H2O2. So always remember, this is also called as Karash effect. This is also called as Karash effect. Usually takes place at the in the form of peroxides. Whenever there is peroxide takes place, where the Markovnikov is taking place, the reverse, that is anti-Markovnikov, will take place. So from B2H6 and H2O2, just simply remember that here H plus will attack at the center one where there is one hydrogen is there, and here two hydrogen is there. So just as simple as that, CH3 CH CH2. Okay, so just simply remember, and here H will attack and here OH will attack. Okay, so this is what the thing you people all need to remember. Okay, I hope everyone is clear with the B2H6 and H2O2. Hydroboration oxidation, remember, no rearrangement takes place. No rearrangement takes place. No rearrangements takes place. Okay, guys, I hope you all understand this one, right? Another example, if I am going to give you, then it will be very clear. CH3 CH CH3 CH double bond CH2, and if I am giving you B2H6 in the presence of H2O2 and tetrahydrofuran, if I am giving you, then what is the answer, guys? Simple, CH3 CH bond CH3, here CH CH2, hydrogen will attack here and OH will attack here. So this here hydrogen will come and here OH will come. Again, no rearrangement takes place. No rearrangement takes place. Okay. Next one is OMDM. OMDM is simply nothing but oxymercuration, demercuration, where there is no rearrangement takes place, but it is also undergo Markovnikov rule. It will also undergo Markovnikov rule. So oxymercuration, demercuration means the reagent will look like this. Okay. So that is mercuric acetate. It will look like that. Discuss this one later in the upcoming class. Okay, guys. Thank you so much for joining the class. I hope you all like the class. Okay. If you like the class, please comment me in the chat box. Then we can leave the class. Is it clear to you all? Is it clear? How do you feel the today class? Did you feel you learned something? Come on, people. Let me know through the chat box, then we can end the class. It's already through 2 minutes late. Thank you. Thank you so much, guys. Right. Okay. See you all in the next class. Bye, guys.